Okay, so this is absolute value functions and transformations. So we've seen absolute value equations. Now we're going to graph them since we've been graphing regular lines. So first off, absolute value function looks like this. F of x equals the absolute value of x. And what we call this the parent function. So basically we want to look at what we're going to get here. So let's see how it's different from a regular line. Okay, so we have x equals -3, and when that happens, well, we know the absolute value means that we take that number and we just make it positive, right? So all of these values, actually, we can just make them positive, and if they're already positive, well, they stay positive, right? So let's go ahead and plot those and see what happens. So -3, +3, that's -3, +3, -2, +2, -1, +1, 0, 0, goes right through the origin, +1, +1, +2, +2, +3, +3. So what we get is this V for all our absolute value equations. And what we call this, again, is a parent graph. So we call it a parent graph because it's a graph of the simplest absolute value equation you could possibly have. It's just x. There's nothing added to it. It's just the absolute value of x. So this is as simple as of an absolute value graph that we can get. Okay? But, you know, this is just the baby food, right? So we have what are called transformations. And a transformation is simply a change to the parent graph size, shape, position, or orientation. So the way this gets difficult is that we start moving or shifting this graph as well as changing how far apart these lines make a V. But a transformation, excuse me, we have translation, and that's what we're going to be dealing with for this lesson. Okay, and a translation is simply a transformation that shifts a graph horizontally and or vertically. So all of our graphs should look like this. They're just going to either move up, move down, move left, or move right. And that's left, that's right. So let's take a look at some examples so we can see what we're talking about. Okay, so example number 1 says graph the function f of x when we have the absolute value of x and it's -3 outside. Okay, so let's think about this. Again, what I did here on the graph is I drew what the parent graph should look like. Okay, so we're going to see how it changes. So -3. If I plug in -3 for x, well, that means I get a +3, right? Because -3, the absolute value of it is +3. So +3 minus 3, well, I get a 0 there. -2 becomes +2. +2 minus 3 is -1, right? -1, excuse me, -1 is +1. +1 minus 3 is -2. And 0, well, 0 stays 0. 0 minus 3 is -3. And +1, well, this time we're going to get what? 1 minus 3 is -2. And if you can see, there's kind of a pattern here. We just went from 0, -1, -2, -3. We're going back up, -2. I'm assuming this next one's going to be -1, and I'm correct, as well as 0, because again, 3 minus 3 is 0. So if we plot these points, -3, 0, I have there. -2, 1, I have there. -1, -2, and 0, -3. And if you can see, we basically have the same thing that we did before. All that we've done from our parent graph is we've shifted, and you want to get used to this term. This is called a shift. We shifted down 3 units. Okay? So whenever you have an addition or a subtraction outside of the absolute value, what ends up happening is we shift up or down. And all that depends on whether you shift up or down is whether it's a positive or a negative. So in this case, since it was negative, we shifted the graph down 3 units. Okay? So now let's take a look at this other function. Example 2 says graph this when it's plus 3. Well, if it's plus 3, this one was minus 3 and it shifted down 3 units. This graph should simply go up 3 units, right? So let's double check. Negative 3 becomes positive 3. 3 plus 3 is 6. This is going to be 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. So let's graph them again. Negative 3, positive 6. We're way up here. Negative 2, 5. And negative 1, 4. 0, positive 3. 1. There. There. And there. So again, you can see our graph has not really changed at all. All that's happened is, we have shifted the parent graph up 3 units. So again, whenever this number out here, whenever there's a number outside of the absolute value that's being added or subtracted, that simply moves the graph either up or down. Since it's positive 3, we moved up 3. Since this one was minus 3, we moved down 3. Okay?